Okay, this is the last of our videos on sketching simple parabolas. So what I want to do in this last video in this series is rather than moving the parabola up and down, I'm going to move it sideways. Okay, so the line of symmetry this time is not the y-axis. Okay, but it's still symmetrical. All parabolas, no matter where they are, all parabolas are symmetrical. But in this particular one, all I'm going to do is make it a sideways move, but just moving along the x-axis. Okay, so we still need to have values, and instead of x equaling 0 as the symmetry line, we've just got to move it to a new value. Okay, so copy that and come across. Copy that and come across when you're ready. Okay, so for this particular one, we're moving the parabola sideways. Don't know why it's doing that. Okay, we have to have what's called a perfect square. Okay, so when you square a number, this number is squared, it must always be positive, so that means that's why it's always above the x-axis. Okay, when you square, this is a number, when you square a number, it's always positive, which means we can't have anything down here. Okay, that's why it's just bouncing off the x-axis. So if it's of this form, then the axis of symmetry, this new value where the curve is symmetrical, is always equal to minus b on a. Okay, and here's the proof of why that's the case. So the reason is, if y equals 0, okay, these are your y values, and that equals 0. So for y to equal 0, we have 0 equals ax plus b squared. You take the square root of 0 to get rid of the square sign. The square root of 0 is 0, so you get ax plus b. Then you move the b across, which makes it a minus b, and then you divide by a. So you end up with this little formula, and that's the axis of symmetry for this type. Okay, when we get onto the harder parabolas, say like y equals x squared minus 7x plus 5, there's another formula for an axis of symmetry, but for this one, it's minus b on a. So copy that down and come across when you're ready. Okay, so I've got x plus 1 squared. So the axis of symmetry, so the formula is minus b over a. So that's the b value. So it's minus 1 divided by 1, which is minus 1. So that means the axis of symmetry is on minus 1. So if that was minus 1, our parabola is going to be symmetrical about that line, and then all you do is just pick numbers on either side. So minus 1, 0, 1, minus 1, minus 2, minus 3. So it's important whatever the gap is that way is the same as the gap that way. So we're going up in ones. Okay, so let's do the 0 squared. 0. If you put 0 there, you get 0. 1 squared is 1. If you put 1, 1 plus 1 is 2. 2 squared is 4. So we're done. So the first values are 1 and 4. So those values are 1 and 4. So 1, 2, 3, 4. And minus 2, minus 3, 0, 1. We don't need 2 because we're not using it. So that's the first one. 0, 1, 1, 4. Minus 2, 1. And there's our parabola. Okay, it has to touch the axis as well. Okay, so copy that and come across when you're ready. We've got one page to go. Okay, so here's another example. Again, it's a perfect square, so it's going to be bouncing. Okay, so the formula is x equals minus b on a. So we take the opposite number, so it's positive 3 divided by 1, so it equals 3. So 3 is a symmetry number. So what's happening is at 3, it's bouncing that way. So our numbers will be 3, 4, 5, 3, 2, 1. Okay, so 4 minus 3 is 1, 1 squared is 1. 5 minus 3 is 2, 2 squared is 4, so it's that same numbers again. We got 1, 4, and so we won't, so it looks like that. And you can draw it properly, but we've already drawn a few parabolas. So that's it. So that's the last one of the simple parabolas in this series. Okay, thanks. See you next time.